and move on to the second page. So here we're pushing something horizontally with a force of 10 newtons, and the box doesn't move. So we're going to have a normal, we're going to have the force of gravity, we're pushing it with a force, and we have a friction force going backwards of 10 newtons. So I hope you realize the pushing force, in order to keep this balanced, is also 10 newtons. Now, similarly, I can take this little guy here, this whole free body diagram for number 5, and just copy the free body diagram with a couple of changes. Whoops. So what's going to happen here is, instead of having 10 newtons, I'm applying a force of 20 newtons, and that means my balancing friction will also be 20 newtons. Finally, we push with 25 newtons and it just starts to move. This idea of just starts to move, I'll tell you right now, we're going to say that's mu static because, again, it is just moving. And whenever you see those words, just starts to move, this means you're at the end of the mu static, just so you know. Now, once we get it moving, if you notice, exactly like we said in class, you need only 21 newtons to keep it moving. So again, that graph that we did of friction versus pushing force actually applies here. I have a friction static, and then it breaks, and then it starts moving. So this is all static, and this is all kinetic, just like the graph we did in class. So when we draw the free body diagram, we're going to have normal, we're going to have weight, we're going to have the pushing force, and we're going to have the friction force. But now this is kinetic friction, again, because it's moving. So what I'd like you to do is write up a summary of these two types of friction, and we're going to go ahead and share those out in class and kind of wrap up this homework.